Hello, welcome to Science Chomp. Today we're going to be talking about geologic history. And just like in the previous videos, I'm just going to rattle through my PowerPoint and we'll see how it goes. So anyway, geologic history is all about the history of Earth. If you have a look at this starter question, it says seconds, minutes, days. What is the longest unit of time you can think of? Most people think of maybe decades, centuries, millennia. But there's units of time longer than this, and when we're talking about the history of Earth, we have to explore these a little bit further. Anyway, before we get into Earth's history, let's look at history of human beings. Let's have a look at this thing over here, right? So this is a standard human. They start off as one of these things for about a month, and then they morph into this thing which crawls along the ground for up to about a year. And then they turn into a child for up to about 12 years, followed by these things, and then into like a respectable adult from the ages of around 20 to 60 years. And then after that, you turn into an old man and then you just die, right? So that's kind of like what happens to humans. Now, the interesting thing is these time divisions aren't exactly the same in length. For example, you got 40 years here, which is bigger than all of those combined, you see? And this one, I mean, potentially it could be long or it could be really short depending on what's written for you. So this just goes to show that your lifetime can be split up into like periods, and they're of unequal length in terms of time scale. And Earth is exactly the same. The history of Earth is divided kind of like this. So you've got eons, eras, periods, and epochs. And again, all of these things vary in length, with this being the biggest and the epoch being the smallest. So on average, eons are about 1 billion years. So we've got 4 eons so far. Currently, we're in the Phanerozoic eon, and we started off the Hadean, so it's about 1 billion, and then billion, like that. Altogether, the Earth is, according to this, around 4.54 billion years old, okay? The next time division is era, so eons could be split up into eras. And an era is, well, like you see, it kind of depends. So we're currently in the Cenozoic era, which is 66 million years old and still going. This one is around 186 million years, something like that. And this one's a big one, it's around 289 million years. Eras get split up into periods, and periods are roughly around 60 million years per period. However, they do vary quite a bit. For example, the Cretaceous, which is over here, is around 80 million years old. The Jurassic is around 68 million years in length. The Triassic is around 35 million years. So they do vary in length as well. And then finally, we got epochs, and they're all roughly around 3 million years. So what you see on the screen right now, this is what you're going to have to remember for your exam, this setup. I know there's quite a lot, but you're going to have to do your best. Here's another way to look at the history of the Earth. So we're starting off the eons over here. So we've got the Hadean, the Archean, the Proterozoic, and then finally these 3 parts here, these are part of the Phanerozoic eon. And we're currently at this stage, this black line, this is where we are right now. So this is an interesting way to look at the Earth's history. Let's just move it along. So here's another way of looking at it, and what this diagram has done is it's blown up the Paleozoic, the Mesozoic, and the Cenozoic era in a little bit more detail, and this is what we're going to be looking at in a little bit more detail in a future video. Okay, So here it just says that the eons are subdivided into eras, which are subdivided into periods, which are then subdivided into epochs. Kind of like how a decade is subdivided into years, which are subdivided into months, which are subdivided into weeks, into days, into months, into minutes, like that kind of thing. Okay? Now, the other question which arises is, why are the time divisions irregular? Okay, and it's to do with rocks. If you have a look at rocks, in amongst the rocks, you're going to find fossils and evidence of life. And you can see that not all of the rock layers are the same thickness. Okay, so originally, when early scientists were putting together this geologic timescale, they were basing it on fossils. Eventually, what they started to do is to base it on major events in the geologic timescale. And the reasons for that is that you'd have a major event like a volcano or an earthquake, and then suddenly it would wipe out a whole load of like organisms, and you'd have like gaps occurring in your rock layers of fossils, right? And because those gaps were irregular, the time divisions were also irregular. So what caused this? Well, it was mass extinction events. So as you can see, a mass extinction event down at the bottom here is the extinction of many species on Earth in a short period of time. So here you've got the number of genera, so basically the biodiversity, and at every mass extinction, this basically gets taken down a big notch. And if you have a look at the Permian mass extinction here, you see like almost all life on Earth is wiped out at the end of this period. And here we've got another mass extinction. So far we've had around 5 mass extinction events, and it looks like we're due for another one any minute, so happy days. Okay, now why do mass extinctions occur? It's because of climate change, and it's volcanoes and meteorites that cause rapid climate change. And a lot of organisms, they can't adapt, and if you can't adapt, you die. Ultimately, what happens is dust gets kicked up, it blocks out the sun, plants die, and then herbivores die. That's animals that eat plants. And if herbivores die, then the carnivores that eat the herbivores, they're also going to run out of food, and they're going to die as well. Okay? This is another time scale. You got the 3 previous eons there, and we call that the Precambrian time, because at the very beginning of the Phanerozoic eon is the Cambrian period. So anything before the Cambrian period is the Precambrian time. And as you can see, each eon is a slightly different length, but like I said, they're roughly about a billion years. Okay. What's interesting is 90% of Earth's history is Precambrian time. Life was thought to have begun in the Archean eon, so you had like very simple organisms like bacteria and like simple photosynthetic organisms which started around here, and eventually you had like a load of oxygen here, and life started to become a little bit more complex, you know. So here it was like unicellular, here it was a little bit more complex, but they were kind of soft-bodied, okay. And before the Cambrian period, a lot of those organisms did die out. However, if I like divert your attention to this bit, okay, this line here represents the Cambrian period, and you can see from that moment onwards we had a massive increase in biodiversity. And what we mean by that was there's life before the Cambrian period, but during the Cambrian period, suddenly you had like millions and millions and millions of different types of organisms, be that insects or plants or bacteria or other things as well. They just massively increased in number, and we call that the Cambrian Explosion. And this is a good example, this organism here, this trilobite or trilobite. It's an example of the type of organisms that you might have found in the Cambrian period, and it had hard body parts, and it was very easily preserved. And that's it. That's the end of the lesson. I hope that makes sense, and I'll talk in a little bit more detail about the Paleozoic, the Mesozoic, and the Cenozoic era in other videos. Thank you for watching.